Sunday, Monday, happy days. Tuesday, Wednesday, happy days. Thursday, Friday, happy days. The weekend comes, my cycle hums, ready to race to you. These days arrive.
Hello, my name is Trujillo.
And I'm Barragan.
And this is the Experimental Ultrasound Imaging Lab. And we work under Dr. Russell Whitty. Oh, there he is now. Hey, y'all.
Our lab's main question is, how can we use ultrasound to explore non-invasive medical imaging techniques? Currently, the highest resolution imaging technique used is functional MRI. However, the mode has an expensive cost, lack of availability to those with magnetic implants, promotes claustrophobia, and the time to receive results can take weeks.
However, with ultrasound, we can decrease imaging costs, increase availability without worry of magnetic interference, and the results can be instantaneous. Therefore, our specific team's main goal is to map electrical currents in the brain and elsewhere in the body using the acousto-electric imaging effect to identify structures, limit invasion, and characterize the current density shape. But first, some background.
The acousto-electric effect is described in this image here. On the right, you can see an equation that directly correlates the change in sensitivity to an interaction constant multiplied by a change in acoustic pressure. That effect is known as the acousto-electric effect. On the left, you can see that this change in acoustic pressure is occurring via an ultrasound probe emitting an ultrasound pulse into this brain. With manipulation using Ohm's law and other known variables, you can then calculate for electrical current.
One of the parameters that directly affects the sensitivity of our signal is the pathway of neuron activity. Therefore, I am optimizing our test chamber to best emulate this pathway. In addition, I manufacture adapters for ultrasound transducers to aid in our design's medical application.
I work with transcranial imaging of current densities in the human head model. This is done to determine detection, sensitivity, resolution of deep tissue currents for a non-invasive scenario. I also write software to visualize the four-dimensional images that I am collecting.
With the results we gather, we hope to transform our acousto-electric ultrasound technique to a microscale so that we can offer a less expensive alternative to invasive brain activity imaging in the medical device market. What other non-invasive tactics can be used for transcranial acousto-electric brain imaging? Will algorithmic calculation of the ultrasound delay based on skull thickness allow for an ultrasound to focus correctly?
What occurs to the ultrasound when it travels through the skull? Is non-invasive acousto-electric brain imaging viable compared to existing electrical brain imaging techniques?